All right, folks, hello. It is 9 o'clock. It's good to see you on this Monday, 9 a.m. Hour of mathematics. I don't know, hour and a half, but hope you're doing well. Hope you had a good weekend. If you do have anything you want to share about your weekend, maybe you can in a little bit. We'll just talk about this, and I'll give you a bit more time to work on it. Find the slope of the line containing these 2 points. And, of course, if I did a quick sketch, I might have 2 points that look like, hey, I've got one here and one like way over here, something like that, right? So we've got those 2 points, and it tells us that they are on a line. So that means that, it would continue on and extend past both of those points. You could use graphing paper and plot those points and count. We count our rise over run. That's kind of what we learned last time. 1, 2, 3, 4, 5, 6, 7, 8, 9, however many it is, right? From one point to another. Or you could use the slope formula that we learned last time as well. So that's y2 minus y1 over x2 minus x1. And so, like I said last time, it's not important whether you make this one 1 and this one 2, or you could do the other way around. That would be fine too. If you made this one 2 and this one 1, that would be fine. But that just helps us organize whether a coordinate is x1 or x2 or y1 or y2. So I'll let you work on that for a little bit, and then we'll continue on with class. All right. I'd like to move on pretty soon here, folks. Are there any questions about this challenge question in front of you? No. Maybe we're good to go. I want to know if there's anything that you want to share about your weekend. How was your weekend? What did you get up to? What exciting things happened, or not so exciting, maybe?
Our mom went out of town, and I made a joke about throwing a party. And she was like, "Okay." So I did, kind of. I invited people, but then everyone kind of last minute was like, "Meh, no, I'm good." And then or they were just like they couldn't make it, and I was like, "Okay." So it was really just like me and like 3 of my friends.
But that's fun too. Actually, I kind of prefer like the smaller stuff. Yeah. So did you have fun, Jonah?
Yeah, we were like up at midnight, me and my drummer, because we have a band, and we were up at like midnight playing guitar, and he was on, do you know what a cajon is?
Yep.
Yeah, he was playing the cajon. So.
Cool. Midnight jam sesh.
While he was having a midnight jam sesh, I was busy arguing with my friend Ben about the days of creation. We were up until 3 a.m. arguing about it.
That's a late night.
We were exhausted the next day.
Yeah, no kidding.
Yeah.
I got my computer back, so.
Yes, you're back without having to unplug your headphones and everything?
Yeah.
Good. Nice. Congratulations. Good. Anyone else?
This candy cane.
Oh man, holy mackerel. That thing, did you get that at school, or like did you buy it over the weekend?
I bought it over the weekend.
Man, Drayden, you could start eating that now and it will last you till the new year, I think.
Yeah, it depends on how I approach it.
Yeah.
The last time I had one, I basically just bashed it to like pieces in certain areas just to eat it.
Oh yeah.
Slowly. Instead of eating like an actual candy cane, because that would take forever.
Yeah. They make I've had something like made out of candy canes that's like crunched up, and then chocolate and like white chocolate and milk chocolate, like kind of in layers. I forget what they call it, but it's
It's called candy cane bark.
Candy cane bark, yeah.
Yeah.
So that candy cane would work well for that. You crush it up and then you, I don't know, you probably don't feel like baking, do you, Drayden? I like baking. Yeah, okay, so there you go. Awesome. Anyone else? All right. Well, today, folks, we are not going to look in our textbook. Today, you don't need your textbook, okay? As I had mentioned a couple times last week, today we're going to talk about putting data into a graph or into a chart. And part of today's class will be just kind of work time for you to take the, I encouraged you to have your data collected for your human behavior project and ready for today. So part of today's class will be an opportunity for you to kind of get that ready and put that into a graph. And I will be, a mode of support to help you get to that point. If you don't have your data ready, you can either put in the data that you do have, or you can use data that you'll be shown today, right? So you can use like some example data to do an assignment today.
Hey, Mr. Gore.
Yes.
So the problem Ruben and I were running into, was like, we even thought, okay, maybe it'd just be easier if we just like team up on the caffeine thing, right?
Yeah.
No one will do it. So we were like, that was the problem. Like we can get three points of data. We can get myself, Ruben, and our friend Max Zelenko.
Yeah.
But like the problem is, and like with any of these things, I find that if you ask them, they're like, oh, sure. And then you're like, okay, when would you be okay to do this? And they're like, whenever. And then you're like, how about this day? It's like, oh, I can't. Like,
the problem when I was asking people was they're like, so either they don't drink coffee or they don't run.
Okay.
Or both.
All right. Well, folks, Ruben and Jonah, then I'll chat with you in a little bit. But rather than changing the assignment, right? Like asking for points of data, what I'd be willing to do is something like an extension, or I would encourage you maybe simultaneously to maybe think about something that would be easier for people to agree to, So if you are encountering a lot of people that don't like to drink coffee, maybe you can do something else like with sugar, or something like spinach. Popeye eats spinach and he can lift like vehicles and things like that. So anyway, so we can talk about an extension, and we can talk about, hey, is there any way that we can change this a little bit? But yeah, we can chat about that in a bit. For now, I just want to talk about a couple of concepts. First is this concept of a scatter, or more commonly called a scatter plot graph. And down here below, we have an example of a scatter plot graph. Okay, that's right here. And so we can kind of see that this is pretty typical, maybe so typical that you've seen something like this before. We have two axes that are labeled. So here on the bottom, we have age of people, and here on the left is the number of times traveled outside of Canada. So this is just pretend data. This is data points that I entered in there. But we can see that a scatter point or a scatter plot graph will highlight for us and maybe easily illustrate if there's any sort of trend or peaks anywhere, or like if this tells us something that older people are more likely to travel outside Canada more, or younger people are, right? So when exploring the connection between two variables, a scatter plot graph can be very useful. Each data point usually represents one individual or trial. So for example, we have a data point right here. And this data point is, of course, representing someone who is about like 42 years old and has traveled outside Canada maybe about, let's say, 3 or 4 times, right? So we can interpret this this point because we can clearly see that it lines up with about 42 or something, right? So it represents someone who's 42 years old, and it would line up over here with about 3 or 4 times traveling outside of Canada. And then we have another point here, let's say this one, right? This is representing someone who is maybe like 15 years old, right? Because if we trace it down to the x-axis and has traveled outside of Canada, actually maybe that's the same amount, isn't it? 3 times, okay? And then we have one down here, right on the axis. So this is someone who is 15. And how many times have they traveled outside of Canada at this point? If it's right on the axis, what does that tell us about how many times they've traveled outside of Canada?
0 times.
0 times, absolutely. So who's traveled outside of Canada the most out of all these points?
Like the 43-year-old.
Yeah, well, this person here, which, yeah, is maybe like 43. If we think there's 40, there's 60. So halfway between this is 50. This might be like 45. And we can also label it like this, right? 45, and they've traveled outside of Canada maybe like 18 times, okay? Notice that like there is not a, there's not a clear line or anything. It's not like all these points where it's kind of useless to go ahead and like graph them as, try to graph them like a function like this. This is useless, right? This doesn't tell us anything at all. Okay, so don't bother doing that. But there is like, we can kind of see some general trend, right? We imagine, or we can kind of see that the younger people have traveled outside of Canada less than the older people in general, right? I mean, there's exceptions to that. This person traveled outside of Canada less than this person, and this person. But in general, there's that general trend. Questions about this so far? This is a type of graph that you are expected to make for your human behavior project. Maybe one graph or several graphs if that suits your data better. And also part of your assignment is to find a trend line. A trend line. So a trend line shows the general trend or direction of data. It can be used to easily see what kind of connection data shows between 2 variables. A trend line tries to be as close as possible to all data points. So we imagine like we can kind of see this, this trend, like we said, it kind of goes up and to the right like this. So if I tried to just draw a trend line, I might draw something like this, right? I'm trying to get as close as possible to all these points. So I want it to be clear to you folks, like why this pink line here is a pretty good trend line, right? That might be pretty accurate. Whereas like if I drew a line like this, that's a horrible trend line, right? It's not close to these points at all, right? That brown one there. Or if I drew a trend line like this, right? Let's erase these other 2 for now. If I drew a trend line like this, it's kind of going through the middle of all these points, but we can see that it doesn't follow the trend, right? We kind of imagine that these 3 points are so far away from the line, right? And this point are far away from the line. Okay. Whereas if we change that line again, if we put it back to how it was before, this kind of pink one here, we can see now that these 3 orange points are much closer. These 2 orange points are much closer. So this is a much better trend line. Have you guys talked about trend lines in class before? Okay. These trend lines are also sometimes called lines of regression. but we're going to refer to them as trend lines. Let's have a look.
He muted himself for the drinking.
I did. I don't know if you've noticed, but I don't do it all the time, but it is something I think about, so that there's no like massive gulping sound coming over the airwaves. All right. We're going to talk about correlation as well. And a trend line, we still see it here. A trend line really helps us with correlation, really helps us see. I mean, have you heard that word before? Can you kind of just offer me a normal English definition of what correlation is? What is correlation?
Correlation is kind of like when two things happen like close to each other, like kind of like correlation. Correlation doesn't always equal causation, like vaccines and autism.
Yeah. Okay.
Like, some people may get autism after they have vaccines, but that doesn't mean that they got it because of vaccines. Yeah.
Okay. So Krista, I like that example. And so Krista is talking about correlation does not equal causation. So we can, maybe you've heard that word correlation before. It's when things tend to happen together, right? But that doesn't mean that one thing causes another. We're going to see some examples of that too. Good. Thank you, Krista. Anyone else have anything to add about correlation? A definition for correlation, or like if I say that two things are correlated, what does that mean? What kind of picture does that produce in your mind?
They're related to each other.
They're related to each other. Okay, yeah, and that's certainly what we're gonna look at. And part of your human behavior project is to find whether there's correlation between what you guys are studying, like caffeine and being able to run fast, or age and memory, that kind of thing, right? All right. Here's kind of a definition for statistics. So see if you can connect this with the understanding that you already have. Correlation is the degree to which two or more attributes or measurements on the same group of elements show a tendency to vary together. And so this is kind of the important part, the tendency to vary together. We talked about it, and it sounds like when things are related. And so what I want to say, the important thing I want to point out here is that it's an ability to vary together. In other words, if age increases, we also expect wisdom to increase, perhaps. Right? Age increases as wisdom increases. There's correlation there. So for example, what did I say? Age, age and number of wrinkles are correlated because older people tend to have more wrinkles. It's true. It's not a perfect relationship, right? You can see 60-year-olds who like hardly have any wrinkles, right? Or you can see like sometimes 25-year-olds get wrinkles. So a 25-year-old could have more wrinkles than a 60-year-old, right? So it's not a perfect relationship or a perfect rule, but there tends to be that correlation. Age and processing speed of computers is correlated. Older computers tend to have lower processing speeds. So this is correlated as well. Let me just
unless it's Mac and you forget to update, and then it just doesn't run at all.
And then it's very slow. Did you say that if it was a Mac?
If it's a Mac and you just don't update once, it just never runs.
I see. It's stuck in the limbo. Okay, let's say we have like 20-year-old computers. So these are older computers. We have 10-year-old computers, and brand new is right here. Brand spanking new, brand new. And we have speed over here on this axis. I'm not putting in like gigahertz, or anything. But of course, these brand new computers, we expect to be faster, right? Some of them are not as fast as others, right? You know, I can start plotting data and it might look like this. Some of these older ones are a little bit slower, right? So we might start collecting data like this. Maybe someone made this really awesome computer a while ago, but still, like, they tend to be on this line here. These 20-year-old computers, really slow. So of course, if we graph our trend line here, you know, we can almost already see where it's gonna be, right? Have a look at this data. You can see where that trend line is gonna go. Something like this. So even though this line is pointing down, we would say that it has a negative slope. It still shows that these two things are correlated. Okay? Sometimes we can say that they're negatively correlated, but they're still correlated. Questions or comments about that so far? All right. We're going to look at a couple of, let me zoom in a little bit here as soon as it's loaded. We're going to look at a couple of collections of data here. Okay, so these are just samples of data that I just made up. So it's not real data, but it's illustrating something. So we're talking about cooking, let's say, a cake or something like that. And we're saying that if you are cooking a cake for a certain number of minutes, maybe someone has taken the temperature of this cake after 6 minutes, after 12 minutes, etc. Right? Notice that we have every 6 minutes for the first 30 minutes, but then there's 2 more points of data. Maybe they made a cake the next day and they only timed it twice. Well, that's okay. We can still use that data. It doesn't matter that it's not in order. Totally doesn't matter. We can already kind of see that there's a little bit of correlation, right? When we have it in the oven the longest, we have the highest temperature. When we have it in the oven close to that, close to 30 minutes, it's pretty high, right? And then it's coldest when it makes sense. That makes sense. But I'm going to show you how this is your first kind of lesson in using Google Sheets for creating a graph. What you can do is you can click and drag your data, including the titles there. You can also click and drag the 2 columns here. Do you see that? I just want to select those 2. And then you can go Insert Chart. So I want you folks to pay attention. I'm going to do it more than once, but just so that that you have this, you're getting used to how this works. So we can go Insert Chart, and it will load up a chart here, okay? This is cooking time and internal temperature. I don't like this chart. I feel like Google Sheets, this is not the kind of chart that I want. So I might have to move my video people over here just so I can see the right side of the screen here, where it's the chart editor. This is a line chart. I'm not happy with it. Do you see where it says chart type here on the right side? I'm waiting for some audio confirmation. Okay, Krista. Okay, Krista.
Yep.
Yep. You can click on that line chart and they have a lot of different charts. You might be tempted to click on some of these. I mean, you can go for it. But what we're really looking for is down here, a little further down. We want a scatter chart, just a regular old scatter, okay? Move right on past all those and put scatter in there. See, this is not, let me try something else. I'm gonna delete the chart instead of, I'm gonna try one more time. Insert chart. Okay, it did, this time it did a bar graph for me, a column chart. That's not what I want. I want scatter. There we go, that's better. So this is what I'm looking for, right? We can see all those points are collected on that graph. It's even come up with axis titles for me. That's kind of nice. And a title of the chart, which is not bad, internal temperature versus cooking time. I might add to that of a cake. Okay. Drayden, see you soon. If I wanted to make a better title, I might just do something like that. Of a cake in an oven, preheated to, let's say, 350 degrees Celsius, right? So I'm just trying to provide detail in my chart title. Anyway, here it is. We can see that there's correlation, right? Those points look so close to forming a line. You know, it's not perfect, but they look so close. And this is often the case with real data. It might not be exact, but it might be close. We can add a trend line. So I'm going to do this by clicking where it says series under customize. There's a checkbox to do trend line, and there it is, right? So that trend line, wow, look at that. So close to all those points. Terrific. All right, so this is what I would call strong correlation. These two things are strongly correlated. When cooking time varies, internal temperature varies as well. All right, let's see some weak correlation. This is what I'm calling weak correlation. This is that number of times traveled outside of Canada. So we'll just look at this data. This is that same data one more time. I went insert chart. Here it is, but I don't want this one. I don't want a column chart. I want a scatter chart. So it's not clear, maybe it's not totally clear where that trend line is. But when I add that trend line, I can go customize on the right here, series, and then click trend line. That trend line helps illustrate how this data varies, right? How they are related. Questions so far? All right. We're going to look at one more. This is no noticeable correlation. So look at what we're measuring. We've got age. So this is the age of a person and the length of grass in your front lawn in inches. So let's say you decided to survey people. You found their ages and then you went out to their front lawn and measured their blades of grass, right? Is there a correlation? I mean, we can already imagine in our minds, it doesn't really make sense that there would be correlation, does it, right? Maybe it's more related to the last time they mowed the lawn. But let's just see what this looks like in a chart. So I'm going to select it, go insert chart. I don't want this column chart. I want this scatter chart. And we can see there's no meaningful trends or anything like that. It doesn't really seem like there's going to be any sort of trend. I can still insert a trend line, but maybe this trend line doesn't really mean much, right? This trend line shows us that older people have shorter grass. Does that make any sense? Well, maybe, like, because they have more, no, they don't have more time to mow the lawn. Maybe they like to mow the lawn more.
With tired people, they just do lawn work, right? That's how that goes?
Maybe. So yeah, maybe there's some correlation, but what I'm calling this is no noticeable correlation. There's this button, show R2. The R2 value, or R squared value, is kind of a measure of how much correlation there is. We're just going to talk about it a little bit, not much. But for example, the R squared value of the length of grass here is 0.14. If we go back to weak correlation, let's edit this chart again. And I'm going to show the R squared value there. This is a higher value. Look at that, 0.46. So there's more, that's telling us that there's more correlation. And then finally, in the strong correlation, I need to edit the chart. I can go to R squared value and look at this huge number, 0.988. 1 is maximum. If you get an R squared value of 1, that is like total correlation. So this is very strong. If you're doing scientific data and you get an R squared value of 0.988, you're gonna write in your conclusion, there was incredible correlation between these two things. anyway, how are we doing, folks? How's this going for you? Any questions? Okay. Just a quick point. Correlation does show whether two variables are related, right? If there is correlation, it shows they're related. Correlation doesn't show whether one thing is the cause of another. This is exactly what Krista mentioned earlier, right? And so, you know, we can even think of something like if I graphed, let's see. If I graph something like this here, where on the axis on the side here, this is number of iPhones, okay? This is number of iPhones, right? And on the left side, and this is, this is, I'm trying to think of something good. Okay, maybe this is not good, but this kind of illustrates my point. Number of deaths per year. I'm sorry, this is a little dark. You know, number of deaths, of course, is increasing every year because we have more and more people in the world. We have more and more iPhones in the world every year too. So like when there were no iPhones, maybe we had some deaths, but as the years went by, we're increasing both the number of iPhones and the number of deaths per year. Look at this. So someone might look at this and say, okay, iPhones are causing deaths in people. But of course, it's not true, right? They just happen to both be increasing because of a hidden third variable, which is that the population of the Earth is increasing. So correlation isn't showing that iPhones cause more deaths, but instead it's showing that, that they're both increasing because of a third thing. So we got to be careful about that. Questions? No? All right, I think what we'll do, we're gonna have our break here, folks. And after the break, I'm gonna talk a little bit more about graphs. You'll get a chance to use Google Sheets. So before you come back from the break, I want you to be aware of a couple of things, or I want you to be ready for a couple of things. Number one, see if you can get your data ready, okay? Get your data ready. And number two, do you have a Google account, right? Do you have an @Gmail account? If you do, maybe you can just make sure you're logged in and ready to go, because that Google account is how you can create your own Google Sheets documents, right? If you're at a school, sometimes your school accounts are Google accounts, so you can use that. So you can do that. Otherwise, you could, if you want to, you don't have to, but it'll help. If you want to, you can set up a Google account. So you could go to, for example, sheets.google.com and you could sign up. It will be very handy. If you have a Gmail account, right? If you have Gmail, this is your Google account. So you'll be logged in automatically. But maybe you can just try going to sheets.google.com to see if you can log in. If not, you can use something like Microsoft Excel or something like that. It'll be a little different, but it'll work. Any questions about that? Then let's take a break. Please do think about those two things while you're taking your break. We will set a timer for 8 minutes, okay? Set a timer for 8 minutes. Try to have these things ready to go by that time. See you in 8 minutes. All right. folks, hello. Welcome back. Evan, you linked in the chat just a link. I think it just goes to, excuse me, the Google Sheets main page.
Yeah, I did that because Hunter couldn't find it.
Got it.
Gave her so she could get to it quickly.
Got it.
Yeah.
Sounds good. Yeah, so folks, there's a link to the spreadsheets page. I think, does it work to just go sheets.google.com? I think so. So yeah, your Sheets website will look something like this, and then you can click a new blank graph there, and it takes you to something like this. Okay. Folks, were you able to get to a screen like this? Are you able to log into Google Sheets and create a graph like this? If you're not, please let me know, or let someone know here in chat. Sounds like Evan is maybe able to help out a bit as well, and anyone else. All right. But folks, I would like you to be able to have some sort of spreadsheet software so that Google Sheets is easy, it's free. Excel, Microsoft Excel, a lot of people have that on their computer. You can use that as well. Questions as you're getting into Google Sheets here? Okay, so I want to point out to you, I want to point you towards an assignment for today, and we're going to split up into groups so that you can, I can connect with people, and so that you can work with the people in that small group. So let's just talk about what this assignment is. So let's clear that text out of here. We're going to scroll down. There is a spreadsheet scatter graph assignment. I just published it, so so you'll be able to see it momentarily. But for now, you can just look at my screen here if you like. Your task for this assignment is simple. Use spreadsheet software to create a scatter or scatter point graph. I recommend using the tips for plotting experimental data. This is something I put together, just helping you put in that data into Google Sheets. If you have experimental data ready, use it. Okay, great. This is a great opportunity to kill two birds with one stone. If your experimental data is not ready, you could use the data included in the tips for plotting experimental data. So I'll just open that up. You can look at it there. And you see a couple places where we are showing age and maximum frequency heard. I want you to imagine that this is data collected where we are asking people to listen to high-pitched frequency sounds, and you can determine what their maximum frequency they could hear is. So this 14-year-old, they could hear 18,000 kilohertz. And et cetera. So you could just type that data into Google Sheets if your own data is not ready. There's some more tips there. We'll look at that in a second. I just minimized it back. Your graph should be a scatter point graph. Feature a title or horizontal axis title and a vertical axis title. Feature a trend line. Show the trend line equation. So those four things. You can submit an image, a PDF, or share a Google Sheet document to submit it. And you can submit it right from that page there. Okay. If you have a question as we're going here, just go ahead and ask. I think that this document here that you can find on this page, this assignment page, is going to be handy for you, right? It's telling you how to get things set up, and then also how to find the trend line and things like that. Okay. Would you like to see me? Actually, what we'll do first, we'll make sure that everyone gets to a point where you have. Let's see, where you have. Where did I put that? Anyway, where you have something that looks like this. okay? You have something that looks like this in your Google Sheets document. You've entered in your data and you've entered in your titles there at the top. They don't have to be bolded, don't worry about that. They don't have to be gray, don't worry about that. But can you enter this into Google Sheets? That's your first task, okay? All right. I'm gonna split you up into groups. Questions before you split up into groups?
I had a question about like my project in general.
Your project in general?
Yeah.
Is that Raquel saying that?
Yeah, it's me, Raquel.
All right. Well, Raquel, maybe I'll join up in your group first, just so that I can talk to you about that. All right. But folks, in the meantime, you're getting started on this assignment by entering your data into a Google Sheet. All right. So I'm going to create those rooms. Please head into those rooms. Let's make it 3 rooms. Recreate. Okay. Good. Yeah, that'll do. So please head into those rooms, folks. All right. Looks like we're just waiting for 1 or 2 more people to come back into the room here. I just wanted to, we're near the end of class here. I wanted to just walk through a couple things with you folks. I'm getting the impression that a lot of us have been able to enter in our data into a spreadsheet and maybe to start creating the chart. This spreadsheet scatter graph assignment, this is kind of instead of your textbook assignment for today. I'm hoping that this quick assignment can take like 20 or 30 minutes or so. Maybe you got it done in class, that would be great. So here it is, this is the assignment, and you can find this tips for plotting experimental data here. You can just maximize it. And like I said, if you don't have your own data ready, use this age and maximum frequency data. Just type that into Google Sheets just like that and do that. And then these steps, like step 3 and on, click and drag to select your data, click insert, and then click chart. And then under chart type, we want to make sure to choose scatter. It will appear on your sheet. You can click different parts of the chart to edit it.
Hello.
Hello. Welcome back. So this means that this is where you're going to click to change the title and the axis titles and that kind of thing. So let me just show you. I got the data right here, right? This is it. So once again, I want to walk through it one more time. Pay attention if you have not been able to do this yet. So I'm going to select, click and drag from the top left corner to the bottom right corner, so you can see how that dragging is working. It selects it all, and from that we go insert chart. So we click insert at the top and then click chart, and it appears, but it's not the right kind of chart. On the right side, then you might have to move your videos if they're in the way. On the right side where it says chart type, click on column chart and don't select line, don't select area. We are scrolling down to scatter. Okay, and there we go. This is your scatter plot chart. It's got this title here, but we might choose to change it to be more descriptive in humans, right? Maximum frequency versus age. And usually we don't have to put the units in the title. Maximum frequency heard versus age in humans. We've got our axes titles here. An important part though is your trend line. So, you know, in your chart editor on the right side, if that disappears, right, if that escapes or just closes, you can click on your chart and click on these 3 dots here, right, and click edit chart. You see that? So click on your chart, those 3 dots, click edit chart, and then you can go to customize. To put your trend line in, you click series here. This is all in those tips. In that tips page, you can follow along with that to do this. Select trend line, and there it is. One more thing you have to do, where it says label none, click use equation. So you've got to come up with the equation, and it appears right here, negative 122 times x plus 18,910. One more thing you can do is you can go to, you can click those three dots. You can say move to own sheet. And then look at this, it becomes like full screen. That's nice, right? It's nicer for printing out and things like that too. And notice that it's just here at the bottom left, it says chart 1. So that's your chart, but the data is still found on a different sheet. So you can click through for different sheets. Okay. Folks, that brings us to 1026. There's no textbook assignment, like I said, but the expectation is that you're working on this, this scatter, what is it? Spreadsheet scatter graph assignment. Spreadsheet scatter graph assignment. All right. So I will dismiss you right now. If you do have any questions, you can stick around and ask. But otherwise, enjoy the rest of your day, and we'll see you again on Wednesday or Thursday. All right, folks? So you're dismissed. But yeah, if you have questions, stick around.
Thank you.
Okay,
Thank
you're
you.
welcome. See you, folks.
See you.
Thank
Bye.
you.
Thank you.
Sorry about the internet.
That's okay. Don't worry about it.
Yeah, bye.
Bye. If you have questions, stick around, but otherwise I'm waving goodbye.